This is a recording of our playbook. Download the playbook, configuration spreadsheet, and eBay lab environment from our website. Welcome to our whiteboard drawing, Enterprise 20 Dialplan build, low-hanging fruit, presence, tail end hop-off, and mobility. We'll finish with some things that are easy, and make some notes about things that are not so easy. For an overview of the Enterprise 20 Dialplan build, see the drawing Dialplan Build Overview. Remember our objectives for the Dialplan from the discussion in Dialplan Overview. In this drawing, we add configurations for low-hanging fruit and finalize the Dialplan. This drawing has two parts: CUCM native presence and tail end hop-off, or TAHO, and mobility, final fixes. Let's talk about a Dialplan component for CUCM native presence. Presence lets watchers monitor the real-time status of a directory number. A watcher is typically a phone. Users can see the real-time status of directory numbers on a phone via special speed dials called busy lamp field speed dials, call lists, and shared directories. We can put restrictions on which watchers can see which lines, who can see whom. BLF speed dials show the status of the configured DN. Here's what BLF speed dials look like when the target DNs are on hook. Here's what a BLF speed dial looks like when the target DN is off hook. Vancouver 59 56002. We can put restrictions on watching. Busy lamp field or BLF speed dials. The subscribe calling search space of the device with the speed dial must include the partition of the DN to which the speed dial points. For call lists and shared directories, the subscribe calling search space of the device displaying the call list or directory must include the partition of the DN in the call list or directory. The BLF presence group of the device displaying the call list or directory must be able to see the BLF presence group of the DN in the call list or directory. We won't modify our Dialplan to support presence. We won't create new partitions and calling search spaces to control who can see whom. That's crazy talk. Enterprise 20 sets the subscribe calling search space to XXX unrestricted no 911 calling search space. We do this everywhere. Busy lamp field or BLF speed dials. BLF speed dials can only be configured by administrators. We have complete control over this, so we do not need to worry about restricting who can see whom. Call list and shared directories. BLF presence groups will be used to restrict who can see whom. Call lists and shared directories are disabled by default. We'll leave them disabled for now and just roll out BLF speed dials. When we want to deploy presence for call list and shared directories, we'll configure BLF presence groups and apply them, and we'll enable presence for call lists and shared directories. Our Dialplan for presence is easy. Set the subscribe calling search space to XXX unrestricted no 911 calling search space. Do this everywhere. Now we can configure BLF speed dials. We'll create phone button templates with BLF speed dials, and we'll apply the templates to phones and configure BLF speed dials where necessary. We'll cover this when we do phone, feature, and user administration. Let's consider what to do for a Dialplan for tail end hop-off. Tail end hop-off, or TAHO, involves routing calls out gateways where the calls are local to reduce toll charges. For example, callers in Winnipeg and Halifax can have long-distance calls to Toronto local numbers routed out the Toronto gateway, the tail end. What should we do? We won't do anything unless it's really easy or we have bills we want to reduce. Only you know when you have bills you want to reduce. When is it really easy? Callers in Winnipeg and Halifax dial using their normal dialing habits, using a 9 and a 1 to reach Toronto local numbers. Let's investigate calling to Toronto local areas 416 and 905. Callers dial this pattern or this pattern. We need to add Tahoe patterns to our list of patterns. This part is easy. We'll use route filters if we have a lot of these. Remember our Dialplan hierarchy? The Tahoe patterns go in the NANP partition. We'll adjust the block local partition to include the Tahoe patterns so that our line internal calling search space block and calling search space will work properly. For each Tahoe location, we point the more specific Tahoe patterns to the XXX Pstn gateway route list we deployed to support AAR. This route list has a prioritized set of route groups. First choice is the XXX Pstn route group containing the site XXX Pstn gateways. If that doesn't work, use the local route group. For our Toronto Tahoe patterns, the Dialplan hierarchy looks like this. Remember that our Toronto site has two route groups, one for testing ISDN type of number and one for testing E.164 addressing. The route list currently reflects this for testing. For Tahoe at the Toronto 55 site, reconfigure the route list to use either the TON route group or the E.164 route group and the standard local route group. What digit manipulation do we need to do to the called party number for these calls to succeed? It depends on the gateway. Called party digit manipulation is easy if your gateway uses E.164 addressing, your gateway uses ISDN type of number, and all NANP numbers can be sent as national numbers. Your gateway will accept calls to all numbers with a 1 in front of them. Our problem is where some numbers in the area are local and some are not. All 416 numbers are local from the Toronto 55 gateway, but some 905 numbers are long distance. And long distance numbers must have the 1 and local numbers must not have the 1. You need to understand how your gateways work. For gateways using E.164 addressing, we have no issue. We globalize these patterns using Toronto 55 called X E164 calling search space. Score another one for E.164. We can be aggressive with tail-end hop-off at our Toronto 55 E.164 gateway. We looked up area codes to treat as local in the Blocking Online's class of service for delayed 7-digit dialing drawing. We'll move all of these patterns from the Toronto 55 local areas partition to the NANP partition. If the gateway uses ISDN and local numbers can be sent as 10-digit numbers of type national, then we can do this. We will use this transformation pattern from our called X type of number calling search space. We can be aggressive here as well and use the same patterns and Dialplan hierarchy as we used for E.164. If the gateway isn't using E.164 or ISDN, but allows local 10-digit numbers to be sent as long-distance numbers with a preceding 1, then we can just send the 11 digits. We programmed the multi-site Pstn simulation so that the Vancouver 59 site works this way. We'll look at this later in the drawing. Once again, we can be aggressive and include any local area code, whether all numbers in the area code are local or not. We can be aggressive with tail-end hop-off at our Vancouver 59 gateway. We looked up area codes to treat as local in the Blocking Online's class of service for no delayed 7-digit dialing drawing. We need to create 11-digit versions of these patterns using either patterns with a 1 or a route filter with area codes. We put all of these patterns in the NANP partition and use the Vancouver 59 Pstn route list. We'll adjust the block local partition to include the new patterns so that our line internal calling search space blocking calling search space will work properly. What if some numbers in the area are local and some are not? All 416 numbers are local from the Toronto 55 gateway, but some 905 numbers are long distance. And long distance numbers must have the 1 and local numbers must not have the 1. In this case, we must build global transformations to correctly strip or not strip the 1 for TAHO calls exiting the Toronto 55 gateway to 905 numbers. This isn't any fun, and we won't do it unless there's a bill that needs to be reduced. We'll just look at area codes where all calls are local. We can use the local calling guide to find the area codes where all calls are local. First, find the local area codes like we did in the Patterns for No Delayed Dialing drawing. Navigate to this address and click on Search Area Code Prefix OCN. This is a great site. Donate. We did. Put the area code, NPA, and office code, NXX, of your gateway in the indicated boxes. We'll use values for our A Bay site instead of our Toronto 55 site because our Toronto 55 site has the special 555 NXX. Our Ashbridges Bay site with a number of 416-691-1036 has NPA 416 and NXX 691. Then click Submit. On the next screen, click here on the NPA NXX 416-691. All of the numbers that are local are listed in the display partially shown here. Any area code shown here can be a local area code at our Ashbridges Bay site. These are the local area codes at our A Bay 691 site. Just look them up in the display. Scroll through the list and find all the local area codes and write them down. This should take all of 5 minutes. Just because some numbers are local doesn't mean all numbers are. Go back to the area code prefix search. On the next screen, click on Rate Centers in NPA 416. The 416 NPA has a single rate center. Area codes with a single rate center are area codes where all calls are local. We can strip the 1 all of the time. For our A Bay 691 site, this is true for areas 416, 647, and 437. This is the same for our Toronto 55 site. Compare this to the 905 area code. We can use any value for NXX to find the rate centers for the 905 area code. We used 555. There is no NXX 555, so the table is empty, but we can still click on Rate Centers in NPA 905. There are many rate centers. Calls to some of them are local and must not have a 1. Calls to some of them are long distance and must have a 1. Building the global transformations to fix the called party number in this case is possible, but time-consuming and prone to error. If you are building an E.164 dial plan, you'll need to do this work. TAHO to the 905 area is not low-hanging fruit. It's lots of work and prone to errors that can cause calls to fail and numbers to be unreachable. If our gateway behaves like this, we'll only add patterns for areas with a single rate center. These were the only area codes with a single rate center for the 10 Enterprise 20 sites. For area codes with a single rate center, the global transformations are simple. For gateways using the called-X discard 9 calling search space, we can add an additional global transformation. For A Bay 691, it looks like this. We won't implement this because our A Bay site has an FXO port, and using an FXO port for TAHO makes no sense. For gateways using the called-X type of number calling search space, we can similarly add additional global transformations. For Toronto 55, it looks like this. Enterprise 20 used the Toronto 55 PRI for TAHO. Here's a summary. TAHO is easy if your gateway uses E.164 addressing. Your gateway uses ISDN type of number, and all NANP numbers can be sent as national numbers. Your gateway will accept calls to all numbers with a 1 in front of them, and there's a single rate center for a local NPA. Tejo is not easy if some numbers in the area are local and some are not. And long-distance numbers must have the 1, and local numbers must not have the 1. Gateways that won't route local calls if they are prefixed with a 1 are badly behaved. These gateways cause us grief. This drawing is continued in Low-Hanging Fruit, Presence, Tejo, and Mobility, Part 2. Part 2 looks at final fixes for mobility.